Arithmetic Progression, chapter number 5. So in many situations of our life, we have to list numbers according to some rules or some relation. So arithmetic progressions are a list of numbers having some property. We will see what the property of arithmetic sequences or arithmetic progression. Before we start the definition, what the arithmetic sequence is, I wish to show you some number sequences or number patterns. So I start with one example situation. We write a list of numbers. So Rina applied for a job and got selected. She has been offered a job with a starting salary $8,000 with an annual increment of $500 in her salary. Her salary for first, second, third years will be respectively $8,000, $8,500, and $9,000, etc. Okay, so I hope you got the idea. Rina got a job in a company, and starting salary is $8,000, and after every year the salary will increase by $500. So if we list the her salary in each year, so it will come like this: $8,000, $8,500, etc. Okay, so this is an example case where we list numbers. Okay, we can check another sequence. Okay, so you can see a ladder, and here the lengths of each rungs, each steps are given. The first step has length 45 centimeter. Then if you go to top, each steps decreases its length by 2 units. So we can write the length sequence of lengths of steps as 45, 43, 41, 39, etc. up to 31. There's only 3, 6, 8 steps. Okay, so this is another situation. These all are just examples. And next one, in a savings scheme, the amount becomes 5 by 4 times of itself after every year. Okay, if you deposit an amount in this scheme, after 3 years, your deposit will become 5 by 4 times. It will increase. Okay, so you can form a sequence of numbers like this. This is another situation, we list numbers. Okay, then another situation, you can see some pictures here. The first picture have only one square, a small square. The second picture, a large square is split into 4 equal squares. And the third picture, a large square is split into 9 small equal squares. Okay, so you want to list a number of squares, small squares in each picture. Okay, so in first picture only 1, in second picture 4 squares are there, in third picture 9 squares are there. There's a simple idea to find the number of squares in each picture. Okay, so in first picture, the side, we can take the side of one small square as 1 unit. So the number of squares is 1 square. Okay, in second square, we can take each side as 1 unit. So the second picture, one side of the large square is 2 units. So the number of squares, number of small squares in second picture will be 2 square, that is 4. And in the third picture, one side is 3 units. So the number of squares will be 3 square, that is 9. Okay, and etc. So if you continue like this, in the next picture, there will be 16 squares, right? 1, 4, 9, 16, 25, 36, 49, etc. Okay. So once again, first example was this. Rina's salary is 8,000 rupees, and after every year, the salary is increasing by $500. A second example, the steps of a ladder, and you move to top, the length of each steps are decreasing. The length is decreasing by 2 units. And third example, in a scheme, if you deposit an amount, after every 3 years, the amount will become 5 by 4 times. So you will get some interest. Okay. The next one, number of squares in each picture. So there are some rules how to write that terms. So if I ask you one question, how many squares will be there in the 10th picture? If you continue pictures like this is a pattern of pictures. So how many squares, small squares will be there in the 10th picture? That means the 10th number in our progression, in our list. Okay?
100.
100, right. So 100 is the answer. So 10 square 100 is the answer. Okay. So there's a rule, right? Here, to get the number in a specific position, we want to take the square of the position number. That's a rule of the sequence. Okay. And if you go to the previous question, previous example, so here take the 5 by 4 times of the previous number to get the next number. And in this sequence, second example, you have to subtract 2 to get the next number. And in the first sequence, you have to add 500 to get the new number. Okay, so these are the rules for these sequences. So if you take any sequence, we can make some rules. Okay, so now we are going to define the arithmetic sequence. So there are two ways I can define the arithmetic sequence myself. Then I can give some examples. The other way is I shall show you some examples. So you compare them to find a similarity, and then you can get a definition yourself. So I choose the second method. I give you 5 sequences. So they all are examples for arithmetic progression. So you can check these, you read these arithmetic sequences and you try to find some similarity. Okay, I give you 1 minute. You read all these sequences, compare the sequences, and try to find some similarity. From these similarities, we can make a definition for the arithmetic progression. So arithmetic progression is a number sequence or list of numbers having some particular rule. Okay, that rule we have to make from these examples. So it is your time. Can anyone say the answer? Did you note any similarity? Can one of you say what's the rule of first one, at least first one? First sequence, how we arrange the numbers in first example?
Adding 1.
Adding 1, right. Very good. Okay. The second one, how we get the next numbers in second one?
Minusing 30.
Minusing 30, right. Very good. And third one, how we get the next? Adding 1 or subtracting 1? That's right.
Adding 1.
Yes, this is little bit confusing. It's actually adding 1. So fourth one, what's the rule?
Adding 0.
Adding 0, very good. Adding 0, yes, very good. And fifth one?
Minusing 0.5.
Minusing 0.5, very good. Yes, to get the next number, we have to subtract half from the previous number, from the preceding number. Okay, so here we won't say the first number, second number, third number. But when we comes to any number sequence, not only arithmetic progression, we'll call each number as a term. Not the term in English grammar, but in mathematics, a term means a number in a list of numbers. Okay, so here the first sequence of 1, 2, 3, 4, etc. we can say the term 1 is 1, the second term is 2, third term is 3, etc. like so. Very simple, right? So I ask you one question, what's the third term in the fifth sequence here? Minus 2.0. Minus 2.0. Okay. So you got what term? What term is? Okay. So now we can have a general similarities among these 5. Then we can make a definition for arithmetic sequence. So you told how many of them have a difference adding numbers. Here first one adding 1, right? A second one subtracting 30. Third one adding 1. And fourth one adding 0. And fifth one subtracting 0.5. So 3 of them are, we get the next numbers by adding a fixed number, a constant number. Okay, and but second and the fifth sequences, to get the next number we have to subtract a fixed number. So we'll see something we have studied before, some negative numbers property. So you know, a minus b. A is a number, b is a number. So subtracting b from a means, adding the additive inverse of b, right? A minus b, subtracting b from another number a means adding the additive inverse. That means negative of that number. Okay, both are same, right? For example, 5 minus 2 is equal to 5 plus minus.
Plus.
Right? Am I right? Okay, so 5 minus 2 is 3.
Yes.
5 plus minus 2 is also 3. Yeah, this is a rule. So you can say, if you ask, if someone says subtracting b, you can also say adding minus b, no problem. Okay, so come back to our sequence. So in the second sequence, we can also say here, to get the next term, we have to add minus 30. So 100 plus minus 30 is 70. 70 plus minus 30 is 40. So now comes to fifth sequence. How can we say like this? Minus 1 plus what is minus 1.5 in fifth sequence?
0.5.
Minus 0.5, not simply 0.5. If simply 0.5, we are subtracting. So in reverse, we can say in fifth sequence, to get the next term, we can add minus 0.5 or minus half. So now we got some similarity in all these sequences. To get the next term, we have to add a fixed number. That fixed number can be positive or negative, and it can be 0. In fourth sequence, the adding number is 0. Okay, so this is the specialty of the arithmetic progression. We will study only such sequences having this similarity. That means starting with a number and adding a fixed number repeatedly to get the next numbers. Okay, such sequences are called arithmetic sequences. Okay, so we will see the definition here. So in all these lists above or the previous slide, we see that the successive terms are obtained by, successive means the next term, obtained by adding a fixed number to the preceding term. Such lists are called arithmetic progressions. Okay, such numbers list, number pattern or number sequences are called arithmetic progressions. In short, we can write AP. And if you write in notebooks, no need to write arithmetic progression all the time. You can simply write AP, arithmetic progression. Okay, so in red ink, you can see the definition. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, so to get the next number, to get each term, you have to add a fixed number to the preceding term. Preceding means the term just before. Here term means number. I just explained. A term means each numbers. Okay, so each terms are obtained by adding a fixed number to the preceding term, the term just before. Okay, except the first term. So that should be clear. Except the first term means, come back to these examples. So here we got 1 not by adding 1 with 0. It's already there. It is the starting point. 1 is the starting point. So the first term in any arithmetic sequence is independent of any previous terms. Okay, but all other terms are depending on how the previous term. Okay, here you can see the arithmetic sequence. Each term got obtained by adding a fixed number except the first term. Such sequences are called, such patterns of numbers are called an arithmetic sequence. Okay, come back to the examples we have seen in the beginning. So the first example, is this an arithmetic sequence? Can tell.
No.
No? Any other answer?
Yes.
Yes. Okay, this is an arithmetic progression, right? We start with the $8,000 or you can simply say 8,000. 8,000. The next number is 8,500, and the next number is 9,000. So we add a fixed number 500. Okay. So what will be the next number?
9,500.
Okay. So it goes like so: 8,000, 8,500, 9,000, 9,500, 10,000, 10,500, etc. So this is an example for arithmetic progression because it follows the definition. Here, to get each number, each term, we have to add 500 to the preceding term, except the first term. Okay, so it follows the definition of arithmetic progression. So this is an example for arithmetic progression. So next example, is this an arithmetic progression?
Yes.
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 Okay. Okay. Very good.
Yes.
Okay. And my question: what number we add here to get the next number? Here,
-2.
yes, -2. Yes. Very good. Okay. 45 plus -2 is 43. 43 plus -2 is 41. So we are adding -2 repeatedly to get each terms in this sequence. Okay, so it follows our definition. To get each term in this sequence, we have to add a fixed number, that is -2, with the preceding term, except the first term. Okay, so this sequence also follows the definition. So this is another example for arithmetic progression. Now check this third example. Is this an arithmetic sequence?
Yes. Yes.
No, no. No.
No.
Okay,
No,
I get two answers. Some of them are yes, and some saying no. Okay, I'll explain. So it's a little bit confusing. Okay, no problem. Okay, so we start from 10,000. To get the next number, we add 2,500. We do 5 by 4 times 10,000. That's keep in your mind. But here in the list, what happened? What added? 2,500 is added. But to get the third number, if you compare the second and third numbers in the list, what we added, you can check here. Not 2,500 is added. Okay, we don't have to find the correct amount added, but it is not same. The added number is not same as what we added with the first number to get the second number. A different number is added. So if it was an arithmetic progression, after 12,500, the next number should have been 15,000. That means 2,500 is adding repeatedly, but it is not same here. Okay, first 10,000, then 12,500 added, then some other number is added to get to 15,625. Okay, so you can say that it doesn't follow the definition. To get each term in this sequence, we cannot add a fixed number all the time with the preceding term. So it doesn't follow the definition. So this is not an example. Is this clear?
Yes.
Yes. Yes.
Okay, then the fourth example. Fourth example, you can see some squares here. So in each squares, we have listed number of small squares, 1, 4, 9, 16, etc. Is this an arithmetic sequence?
No.
No?
No.
Sir.
Yeah, it's definitely not an arithmetic progression because there is no fixed number adding. 4, we can say 3 is added. To get 9, 5 is added. Then 7 is added. So the number we add to get succeeding number is not same. So this doesn't follow the rule of arithmetic sequence. So this is not an arithmetic progression. Okay. So these two are examples for sequence which are not arithmetic progressions, and the first two are examples for arithmetic progression.